All right, last problem from the limit sequence. I know it's quite a lot. Keep in mind that the professor will only pick a couple of these, but you just can't really know which ones he'll pick, so you need to be prepared for all of them. But in terms of like time on the exam, you should not worry about it too much. Although it's a little bit tight, at least it was tight for me back when I was doing the course, but it's not going to be all of these problems at once, right? Okay, so this is one that we've already seen in a slightly different form, but it's again one with modulus, and the main solving principle will be the same. Okay, so we have limit as x approaches minus 3 of modulus of x squared plus 4x plus 3 over x squared plus x minus 6. Okay, and now before writing down the value of the modulus, what I could do is I could try to factor these out because these are both quadratics, right? So let's do a little bit of practice. For the top, I need two numbers that when multiplied give me 3. Well, this could be 3 times 1, could be minus 3 times minus 1, right? Do we have any other options? Well, not really. And then out of these, I need to find a combination that when summed gives me this value, 4. Well, 3 plus 1 is 4, so this is my pair of values that I'm gonna plug in. So I can factor this out. I still keep the modulus for now. I can factor it out into x plus 3 times x plus 1, right? Look at how easy and neat this is. I really love this method. It's much shorter than the discriminant one. By the way, you cannot always use this method very easily. For example, if you have a coefficient in front of the x squared, it's going to be slightly harder. So then you can just use the discriminant. But I think for easier cases, this method is very easy and convenient. Okay, so in the denominator, let's think about it. So firstly, again, we need two numbers that when multiplied give me minus 6. So this could be minus 3 times 2, or 3 times minus 2, or 6 times minus 1, or minus 6 times 1, okay? Is that right? Yeah, it's right. So out of these four pairs, I need to find the one that when summed gives me 1 in this case, right? So minus 3 plus 2 is minus 1, not quite. 3 minus 2 gives me 1, so that's the perfect pair, right? So I'm gonna write down x plus 3 times x minus 2, right? This is my solution here. I forgot to copy the limit, by the way, so let me correct this mistake because it's important. Okay, so I need to still keep the limit in front. Limit as x approaches minus 3. And at this point, I cannot simplify any further. I cannot directly cancel things out while I still have the modulus, okay? So I'll first have to deal with the modulus and then hopefully cancel things out. What was the scheme with the modulus? Let's just go over it once again. So when I have a modulus of something, there are two options. So if the original expression inside was positive for 0, so if x plus 3 times x plus 1 is already greater than or equal to 0, then the result of the modulus would be this same expression, completely the same, right? So it would be x plus 3 times x plus 1, okay? I need more space, so I just erase this. I don't need it. Okay. So if the original expression within the modulus was already greater than or equal to 1, then the result of the modulus would also be the same, right? Because if I have modulus of 5, then the result is just the 5, okay? We don't change it. But if the original expression, x plus 3 times x plus 1, was negative, then the outcome of the modulus would be the same expression but with a minus in front in order to make it positive, because minus minus gives us a positive, right? So it would be minus x plus 3 times x plus 1, okay? Because if I have modulus of minus 5, then the result would be minus 5, which is positive 5, right? That's how it works. That's something I showed in the previous tutorial too, so I hope it's clear. But now, in order to determine exactly the boundaries of x, right, because this is like a whole expression, but I need to know the exact boundaries of x. So, for example, I need to know that this is the value for x between this and this number, not for an expression. So how do I find this? Well, here's how I do it. I draw a number line somewhere. It doesn't really matter where it will be. And I plug in the roots of the... So for just a bit, I ignore the greater than sign here, and I just think about x plus 3 times x plus 1 equals 0. So for which values of x would this equal 0? Just for a moment, okay? So this would equal 0 for x equals minus 3 and x equals minus 1, right? So for minus 3 and minus 1, okay? All right. And then this clearly forms 3 distinct intervals, right? This is the first one, second one, third one, okay? And now we need to check for which interval do we have positive values and for which do we have negative values, okay? So, how do we do it? Again, I just like to pick a value from one of the intervals. So for example, I could pick the 0, which is in the third interval somewhere, and I plug it in. So if my x is 0, then I would have 0 plus 3 times 0 plus 1, which is 3 times 1, which is 3. This means that this range here from minus 1 to plus infinity is positive, okay? And if I try, well, these will just alternate, right? I told you that most of the time they alternate, unless you have some second exponent, but now we don't have exponents. But you could also try the other two as well. You could plug in like a minus 4 and you'll see that you get a positive number. You could try like a minus 2 and you get a negative value. But just for the purpose of this video, I'm not going to test every single interval. But that's how it goes. So if I care about where it's positive, I would have minus infinity to minus 3 and minus 1 to plus infinity. So this expression is greater than or equal to 0 for x between minus infinity and minus 3 included, and minus 1, this one, minus 1 to plus infinity. Therefore, when would this expression be negative? Well, everything in between. That's going to be x between minus 3 and minus 1, okay? That's the extra step that you need to perform here. And from here on, it's pretty much the same as the previous modulus problem that I showed you. So I need to calculate the one-sided limits, right? So I'm going to start with the left-hand side limit of x squared plus 4x plus 3 over x squared plus x minus 6. So because I know I'm approaching 3 from the left, that means that my x is less than 3. So if it's less than 3, then I'm going to be in this interval, right? Because this interval includes minus 3 and below. So if it's less than minus 3, then I'm going to be in this interval. Therefore, I'm going to use this formula for the modulus. Okay? So now instead of the modulus, I'm just going to write down this thing. So that's x plus 3 times x plus 1 over x plus 3 times x minus 2. And then I can cancel these two out, right? And I can just try to plug in minus 3 for x. So everywhere, of course. So in the numerator, I have minus 3 plus 1, which is minus 2. In the denominator, I would have minus 3 minus 2, which gives me minus 5. Therefore, the answer for this particular left-hand side limit is 2 over 5, or 2/5. Okay? Now, for the right-hand side limit, it's going to be nearly the same, right? I'm just going to copy this. However, this time I'm approaching from the right, like this. And now I just copy the limit. But instead of this expression, so if I'm approaching minus 3 from the right, this means that my x is going to be slightly greater than minus 3. Okay, so it's going to fall in this interval. So the one above is up to minus 3. This one is above minus 3 up to minus 1. Therefore, I'm going to use that expression for the modulus. Okay, so I'm going to have, instead of the modulus here, I'm going to have that expression, which is minus x plus 3 times x plus 1 over the denominator. We already factored it out, so it's x plus 3 times x minus 2. And then I again cancel these two guys out. And I'm left with limit as x approaches minus 3. Now keep in mind we have a minus in front of these parentheses, so it's going to be minus x minus 1 over x minus 2. And now if I plug in minus 3 for every x, this is going to be minus 3 minus 1 over minus 3 minus 2, which gives me 3 minus 1 over minus 5, which is minus 2/5. Okay? Now, what was the final step? The final step was to check if the one-sided limits are equal. In this case, are they equal? Well, not really. Almost the same, but this one is minus 2/5 and this is 2/5. So they're actually not really the same. They're even on the different sides of the zero, so not really. And because they're different, it follows that the general limit, I'm not going to fully write it, but the general limit, the two-sided limit, does not exist. Okay? Just like in the previous modulus problem. Most of the time it will not exist, but keep in mind that sometimes you might get the same values of the limits. And if they're the same, then the limit exists. Alright, that was everything for the general limits. I know it can be tiring, so maybe at this point just take a break if you haven't taken a break already. Give yourself a little bit of time to rest, and then you can come back to the rest of the problems for the midterm.